All right, guys, so what we're looking at today, we're starting off with this here. We'll more talk about it and not do too much with it, is the square root of a negative number property. So if r is a positive real number, then the square root of negative r is I square root of r. Well, if we say r is 3, well, according to the first part, the square root of negative 3, well, the negative would come out as I, and we would have the square root of 3. You're welcome. Now, the second part, according to the first part, if we take I square root of 3 and square it, we'll just get back to negative 3. Because the square root of 3 squared is 3. I squared would be negative 1, so we would end up with negative 3. Any questions on any of this here? Okay. Now, the main first thing we're going to look at is solving quadratic equations with complex solutions. Now, we look at this first problem here. We have x squared plus 4 is equal to 0. Now, with this one here, we can use the square root method to solve this. We can use the square root method to solve this problem. Now, we can't graph it because, again, as I said, it has complex solution, imaginary solutions. So the graph of this function would look something like this here. It will not factor. We won't be able to factor it like we've been doing on ones before. But the closest thing we can do to solving it is the square root method. Now, we know that we can use the square root method because the only variable that we have is x squared. Now, the first step in the square root method is to get x squared by itself. So we can do what to both sides? Subtract 4 from both sides. There's 4 minus 4 is 0, leaving us with x squared is equal to negative 4. Then our next step would be to square root both sides. And the square root of x squared, well, the square root and the square would cancel, leaving us with x is equal to plus or minus, because anytime we square root both sides, we need the plus or minus. Now, the square root of negative 4, well, the negative we know is going to come out as I. And what is the square root of 4? So the square root of negative 4 would be 2i. Then we have the plus and minus. So for this one here, x is equal to plus or minus 2i. And that would be the solution. Any questions on this here? Any question on anything we've done so far? Let's look at the next one. 2x squared minus 11 is equal to negative 47. 2x squared minus 11 is equal to negative 47. Now, again, we can't graph this one, and factoring won't work, but the square root method will. So what can we do first? We can add 11 to both sides, which will tell us that 2x squared is equal to negative 36. So then you got square root of 2x. Almost. We want to get this x squared by itself, so we would divide both sides by 2, which will tell me that x squared is equal to negative 18. And now we would square root both sides. So once we get x squared completely by itself, then we would use the square root, because the square root and square would cancel, leaving us x by itself. Now we need to take the square root of negative 18. Well, we would have plus or minus. A negative would come out as I, but we do need to take the square root of 18. Now, 18 is not a prime number, so we can't just take the square root and get a whole number. But 18 is 9 times 2. Well, what is the square root of 9? Square root of 2. And that would be our answer. Any questions on this here? Okay. Now, the nice thing with this is that if we do have x squared or a set of parentheses squared, we can use the square root method and it will work every time. But not every problem will be set up so that we can use the square root method. Now, if we were able to get it in a form that we could use the square root method every single time, that would be very helpful. Now, we'll skip that one and we'll look at this one here. Because if we could rewrite the equation so that we can use the square root method, that would make it easier to solve a lot of these problems. Now this one here, because normally we would move the 100 over to get it equal to 0, but there's something interesting about this one here. Now if we went on and just factored x squared minus 16x plus 64, if we factored this, well, we would have 2 sets of parentheses with 3 spaces. Since the 64 is positive, the signs would be the same, and they match the sign of the middle term, which is negative. So both of these here would be negative. Now we need to find the factors of the first and third term. Well, the factors of the first term would be x and x. What would be the factors of 64 that we would want to use? And 8. Because 8 times 8 would be 64, and negative 8 plus negative 8 would be negative 16. Well, these are the same thing, so I could just rewrite this as x minus 8 what? Squared is equal to 100. Well, x squared minus 16x plus 64 is what we call a perfect square trinomial. It is a polynomial that can be rewritten as a set of parentheses squared. Well, that's kind of nice because now that I have it as a set of parentheses squared, we can use the square root method, square root both sides, and solve. Because here the square root and square would cancel, leaving us with x minus 8 is equal to plus or minus square root of 100 is 10. What would we do next? Add 8 to both sides, which will tell me that x is equal to 8 plus or minus 10. Now at this point here, can I do 8 plus 10 or 8 minus 10? Well, yeah, we can add and subtract those, so we'll need to. So we can say that we have x is equal to 8 plus 10, and x is equal to 8 minus 10. Well, 8 plus 10 is 18. 8 minus 10 is... So those are our solutions. Bless you. And that's it. That's all we would need to do to solve this. Now this is nice because if we do have the polynomial that is a perfect square trinomial, we can rewrite it as a set of parentheses squared, square root both sides, and solve. Now, will every single polynomial be able to be rewritten as a set of parentheses squared? Well, no. And that's where we're getting into the next property, or the next way to solve quadratics, which is by completing the square. what we're going to do is we're going to manipulate the equation so that it is a perfect square trinomial, so that we can rewrite it as a set of parentheses squared, and then we can solve it. Well, the first main step in doing that is, well, turning a trinomial, a three-term polynomial, into a perfect square trinomial. We're going to try to find out what value of c will make it a perfect square trinomial. And the way we do that is by using the formula c is equal to b over 2 squared. This here, c is equal to b over 2 squared, bless you, will give you the value of c and give us the value of c that will turn this x squared plus 14x into a perfect square trinomial every single time. And again, this is going off of the general equation, ax squared plus bx plus c. So if we want to find the value of c, we're taking b divided by 2 squared. Well, looking at this polynomial here, what is the value of b? 14, because bx, the number in front of x, is b. And here it would be 14. And it's positive because it's plus 14. The value in front of b is positive. Well, 14 divided by 2 is, and 7 squared is 49. So for us here with x squared and 14x, our perfect square trinomial will be x squared plus 14x plus 49. The value of c that makes this into a perfect square trinomial would be 49. Now the only thing we need to do is to factor this. Well, we know we'll have x and x. Since the constant term is positive and the middle term is positive, the signs are the same, and they match the sign of the middle term, which would also be positive. Now we just need to figure out what factors of 49 we would want to use. What times itself is 49? So 7 and 7, or really we could say that this is x plus 7 squared. So we end up getting this plus 7 inside the parentheses squared. Is there another place that we've shown up here so far that had a positive 7? Should be. Didn't we have positive 7 inside the parentheses before we squared it? Well, yes. Whatever the number is inside the parentheses before we square it will be the number that goes right here with its sign. So if it had been negative 7 inside the parentheses, we would have had x minus 7. It will match up every single time. Any questions on this here for how to find the value of c? Okay. So let's look at this first one here, or this next one. So we just want to find the value of c and rewrite it as an expression of a binomial squared. So we look at this here, c is equal to b over 2 squared. Well, what's the value of b? 8 divided by 2 is, and 4 squared is 16. So the general equation for this polynomial, or a perfect square trinomial, would be x squared plus 8x plus 16. Now we do need to factor it to a set of parentheses squared. We know we're going to have x, but what else would go inside the parentheses? Plus. plus 4. Because the number inside the parentheses 4 we squared will always go into our binomial. Since it was 4 before we squared it, positive 4, our set of parentheses squared would be x plus 4. Questions on this here? Let's look at the next one. C is equal to b divided by 2 squared. For problem number 2, what is the value b? Negative 2. Well, negative 2 divided by 2 is negative 1. And what is negative 1 squared? Just 1, because negative 1 times negative 1 would be positive 1. So the general, or the trinomial that we have now is saying that it's x squared plus, yes, would be x squared minus 2x plus 1. We'll plug the value of c back in. Now our binomial that's being squared would be what? X minus 1. Value of c, our binomial. Any other questions on this here? Let's look at the last one, x squared minus 9x plus c. Well, c is going to be our b over 2 squared. Well, what's the value b? Negative 9. Can we take negative 9 divided by 2 evenly? No. We'll leave it as a fraction. For what we'll do and when we solve, it's going to be easier to solve this with a fraction than it is with a decimal. Because as we saw last week, at some point we're most likely, when solving, going to have to take the square root of both sides. A little bit easier to deal with a fraction than it is a decimal. Because we took last week the square root of 25 halves, which we ended up seeing as 5 over the square root of 2, and we were able to simplify it from there. Because if we turned it into a decimal, well, we would be looking at 12.5, taking the square root of 12.5. That's a little bit harder to do, especially looking at it and trying to work through it, than it is if it's in fractional form. Here we can go on and square it. Well, negative 9 times negative 9 is going to be positive 81. 2 squared is 4. So our equation that we have would be x squared minus 9x plus 81 fourths. Inside the parentheses, we're going to have what? X minus 9 halves. And that's it. Any questions on any of this here? Any questions on how we found the value of c or our set of parentheses squared? Now the real nice thing with this here, this part of the steps, and what really is going to lead into completing the square, is that it now allows us to rewrite any quadratic into a perfect square trinomial, and therefore we can use the square root method on any problem. Now, completing the square has 4 main steps to it. The first main step is a equal to 1. If not, make it so. We need to make a 1, and that's really talking about, well, ax squared plus bx plus c. We're talking about the term in front of x squared. Is it 1? If not, we've got to make it be 1. The second step, get all the constant terms away from the variables and leave 2 spaces. Get the constant terms by themselves. So we want the terms with x squared and x to be on one side of the equation and everything else on the other. The third step, find the value of c is equal to b over 2 squared and plug it in. And lastly, find the perfect square trinomial and solve. We're going to do 2 of these here today, and we'll work more with this again tomorrow. So the first problem that we'll look at out of the 2 we're doing today is x squared minus 10x plus 7. Now we can always check and make sure that x squared minus 10x plus 7 is not a perfect square trinomial. I can't rewrite it as a set of parentheses squared, and that won't work here. So the next thing is a equal to 1? Is the number in front of x squared 1? Well, here it is, because if a number is not written there, it's automatically 1. Our next step is to get all the numbers, all the constant terms, all the numbers without a variable, on the same side away from the variables. So here we would subtract 7 from both sides, which when we subtract 7, well, 7 minus 7 is 0. So we're left with x squared minus 10x plus blank is equal to negative 7 plus blank. Now we leave this space there because, again, we're going to find the value of c and plug it in. Any questions on this here so far? So c is equal to negative b over 2 squared because we're using this to get a perfect square trinomial. Now the value of b in this case is what? Negative 10. Because the b value will be in front of the x term, and that is negative 10. Now we have negative 10 divided by 2, which is negative 5. And negative 5 squared is 25. So that tells us that x squared minus 10x plus 25 is a perfect square trinomial. However, if I add something to one side, we have to add it to the other side to keep everything balanced. Now, because we added 25 because we knew that would make it a perfect square trinomial, means that I can rewrite this as a set of parentheses squared, which would be what? X, then what? X minus 5, because again, the number that goes inside the parentheses with x will be the negative 5. So we have x minus 5 squared is equal to, we have negative 7 plus 25, which is 18. So by doing this step, and really what we did here is the completing the square steps, we now have it set up in a form where I have a set of parentheses squared is equal to 18. Now we can use the square root method, which means we would square root both sides. And here the square root and square would cancel, leaving me with x minus 5 is equal to plus or minus. Now the square root of 18 would be not 9 squared root of 2. It would be 9 times 2, which is 3 square root of 2. Square root of 19 is the same as 3 square root of 2. And last but not least, what do we need to do? We would have to add 5 to both sides, which tells me x is equal to 5 plus or minus 3 square root of 2. Now, is 5 and 3 square root of 2, are they like terms? Because what is 3 squared root of 2? It's, well, 3 times whatever the square root of 2 is. So can I add 5 just directly to it? Well, no, not without turning 3 squared root of 2 into a decimal. So that's the answer. Because on the first one where we had 8 and 10, well, I can do 8 plus 10, that's 18. 8 minus 10 is negative 2. We can add and subtract those. Here, for us to be able to add and subtract 5 and 3 square root of 2, I have to turn 3 square root of 2 into a decimal number, and then I can move on from there. Any other questions on this here? Now this here, this problem, would have been very challenging to solve it by, well, we couldn't solve it by factoring because 3 square root of 2 tells me that this is not factorable. It also means that graphing would not have helped us out either. But this one here, no matter what the answers are, we will still be able to find the solutions to the equation. Let's look at the last one. X squared minus 18x plus 5 is equal to 0. So if we look at this one here, now it's not a perfect square trinomial, and the value of a is 1. The number in front of x squared is 1. So our next main step is to get the variables by themselves and the constant terms on the other side. So we would subtract 5 from both sides, which will tell us this over here is x squared minus 18x plus blank is equal to negative 5 plus blank. We leave 2 spaces for when we plug in the value of c back in. Now c in our case is equal to b over 2 squared. For this equation here, what's the value of b? Negative 18. Negative 18 divided by 2 is negative 9. And negative 9 squared is 81. Any questions on this here so far? Now on the left-hand side, we can rewrite x squared minus 18x plus 81 as what? Parentheses x. Then what would we have? Minus 9 squared is equal to, well, negative 5 plus 81 is 76. And what do we do next? Square root both sides. And when we square root both sides, over here the square root and square would cancel, leaving us with x minus 9 is equal to plus or minus well, the square root of 76 is going to work out to be 2 square root of 19. Then we can add 9 to both sides, which is telling me x is equal to 9 plus or minus 2 square root of 19. And that's as far as we can take it. That is the answer, unless we want to turn it into a decimal. Now, completing the square and what we just did is the first method for solving quadratics that works every single time. Because if you notice for this here, no matter what the setup for the quadratic is, we can turn it into one that can be rewritten as a set of parentheses squared, and we can use this square root method to solve. And that is all we are doing for today. Now, problems 3 and 5, it is asking you to solve the quadratic equation. Solve for the values of x that will make the function be 0. Now, those two there, 3 and 5, are already set up in a way that can be rewritten as a set of parentheses squared. They're already written a perfect square trinomial. So we don't have to do anything to adjust or modify it to make it be a perfect square trinomial. If you want to use the steps and methods that we did for the last two to solve it, you will get the same answers. 11 through 18, you're finding the value of C as well as the set of parentheses squared are the two main things you're finding. And that is it.